Hi, this is a video about HexToolkit. This is version 3.1 of the program, and it's available on the Windows 10 store or available from www.binaryEarth.net. Okay, so what this tool does is allows you to open binary files, and it helps reverse engineer them if that's what you want to do. You can also edit them and that sort of thing. So on my desktop here I've got a Esri shapefile. So that's got three different files: a shapefile, a SHX file, and a DBF file. So just open the SHP file. When you first open a file in this program, it shows the hex view with 16 bytes across the line and the character representation of that data. So in this case, there's not a lot of useful characters, strings there. So what you can do is change the way the representation of the data on the right. So if you want to view it as, for example, 32-bit integers, you can choose that. 32-bit integers, of course, being 4 bytes. Now you can resize the tool and drag the windows around so you can see what you need to. Sometimes, depending on the file format, you might need to do a byte swap. In this case, it is byte swapped, so it's not the usual Intel order; it's the Motorola order. So I happen to have a spec for this file format here, and the file should start with a code at the start, a value 9994, which you can see there, and down at, according to this spec, down at byte 24, we should have the file length. So down the bottom is this handy expression tool. So I want to convert 24 into hexadecimal because this tool, HexToolkit, mostly works in hexadecimal. So we type in expression, just type in 24, and that converts it to decimal and hex. So the offset we want, according to this spec, byte 24 is the file length. So we've converted 24 into hex, so that's 18. So we go across here, and it should be these 4 bytes here. So what we can do is we can right-click on those and go copy and paste into byte converter. They'll copy it into here, and then we can press convert. We need to byte swap it, and that will give us the file length. In this case, it's in 16-bit words, so we need to then calculate an expression. So in the expression window here, you can type all sorts of things. You can type mixed hex and decimal. In this case, I'm just going to multiply that value by 2 to get the actual file length. So the file length in bytes then is 2332, or 0x91c in hex. So we can just check that by pressing the end button. That'll take us to the end, and as you can see, the last byte here is 091b, which is corresponds to the length of the file. We just press start to go back to the beginning. If we want to go to any particular offset, for example, offset 500, we just type in 500 hex, we just type in 500 and press go to, and they'll take us right there. You can go back to the start. Now, if we want to find a particular byte pattern, we can find a string. So if we want to find a string like hello, if we want to find a string like hello, we can search for that, but it says not found. So if we want to search for a particular byte pattern, we can choose to search for a particular set of bytes. So I think we go let's try that. Yeah, okay, so that's found that. Let's try a different byte pattern. So if we want to search for OXEA 0x72, and that takes us to the first location of that, and we see, there's actually a few more occurrences of that byte pattern, and then when there's no more, it'll go back to the beginning of the file. Okay, so you can search for strings, bytes. You can search for not this byte. So basically, if there's a whole lot of repeats, you can search for the first byte that's not 0. So in this case, 27. You can also search for a wide string. So what this is if you type in a string, it's actually searching for the characters separated with zeros, so it'd be H0, E0, L0, etc. So that's a wide string. So you've got those options for searching. Okay, so for data interpretation on the right-hand side here, you've got characters, of course, and if it's a non-printable character, it'll just show up as a dot. You can choose just 8-byte integers, 16-bit integers, 32-bit integers, 4-byte floating point, 8-byte doubles, and binary, if you really want to see the bit patterns. So for example, 27 here is 2 and 7. And EBCDIC, if you're interested in that old character set, you can choose that too. Some of the older formats might use EBCDIC, but generally the ASCII characters, which is this first one here, is the most common. And okay, so for each of those data types, we've got this byte swap flag option, so we can choose to byte swap them. So that depends on whether it's the Motorola or Intel order, most significant byte or least significant byte order. So generally, within a given file, it'll either be byte swapped or not. So you can just try both options and see which one it is, and if you don't know. So that applies to all these sort of numeric types. Okay, it doesn't apply to characters. So what else you can do here? Okay, so I might want to see if there's any double values. And I can see down here there's some values that are showing up as doubles. Now, the thing is, you can also step through the file one byte at a time if you want, by choosing a step of 1 and then going down, down, down. And you can see over here that the, if we go back to the start, it starts off at 0 and we go click 1, 2, 3. So we're actually moving only 1 byte through the file. Now what this does, if you've got a data interpretation of like doubles, it will change the alignment so you'll actually see different values appear. So you'll see those values there. Okay, so if we go back to the spec, what we're trying to look for here. So at byte 36, there should be the bounding box, which is an X min value in doubles. So let's see if we can find that. So byte 36, so convert it to hexadecimal again. Okay, we can actually choose this go to button, it'll just take us directly there. And then we can see that there's a value here that looks like a double. And if we byte swap it, it doesn't look like a double. So it would appear that this file is not byte swapped. And so that's xmin, ymin, xmax, ymax, xmin, ymin, xmax, max. So that seems to make sense. And then probably got z, and zmin, zmax, zmin minus 90, zmax. Okay, so that's interpreting the data on the left here as the actual values it is. It should be in the file. Okay, so that's the basics of what you can do. The expression editor here, I'll just show what you can do with this. So if you've got an expression that is mixed, so you say you start at address 1000 hex, and then you want to add 55 lots of 8 bytes, for example. You don't need brackets in that case. It knows the order of operation. So 55 rows of 8 bytes. Calculate what that offset is, and then we can go to it if we choose to go to that location. Actually, it's past the end of the file in this case. Wasn't a good example. But also, if you want to, you can put brackets around it. 5 plus 4 times 3. So what will that be? There we go. So that's most of what you can do. Okay, so now the other thing you can do with this program is you can edit bytes. So for example, if I decide that I want to change the file length. So this was the file length, wasn't it? Let's just do a convert on that. Convert bytes. So that's 1166. If I wanted to change that, so say I wanted to make it 1180, what would that be in hex? 049C. So change that to 9C. Okay, so we've modified the file. Now if we want to write it, we'll, would you like to update the file? Yes. Okay, so then it shows up as red, the byte that's changed. Now if we do a convert byte on that, Yeah, so we've changed it to 1180 instead of 1166. 1166 was it? Yeah, I think so. Okay, so we can edit the file like that. What we can also do is if we're in character mode, actually I don't think we need to be in character mode, but if we want to put different characters in there, we can go, let's try this. We can go, put an apostrophe, and then the character. So what that'll do is it'll convert that to the ASCII characters. So we press right on that, and then as you can see, it's updated the bytes there to the correct ASCII characters, and then in the character view on the right, it's shown those characters. So I don't really want to modify this file, so I'll put it back to the way it was now. So that was that, and I think this was 8E from memory. So we'll just write that back, and just double check that that's still the correct value. Yep, 1166. Okay, so the file should be back to normal now. We can press reload again if we want to reload it, so you can see that the red is gone now that we reloaded it. We can do a hex dump, so let's try that. Save that to a file, and it's over here. Let's see what that's created. Okay, so it's just written out the hex dump basically as you see it in HexToolkit. All the data in case you want to view that and edit and print it out or whatever. So you can do that. Got a few more things up here. So you've got control over the toolbars. You can turn on and off any of these toolbars if you don't want to see them. So the toolbars are just these toolbars here. Probably easy just to have them on mostly. There's also this field layout tool. Now the idea here is that you can, it was kind of an experimental tool to allow you to create C structures and C++ structures from the file layout as you're reverse engineering it. So I'll call this, so as I'm reverse engineering, I can bring up this tool and I can just type in the definition of the fields as I discover what they are. So we've got one float, and that's maybe the X, and let's put another one in. Oops. So another float, which is the Y, and we could just say for a description if we want, name of the file, origin X, origin Y, so just some comments, and we can save that. That just saves it to a layout file, so we can just load it later if we want. We can close that tool, and it's created the layout file here. I just open that in a notepad. Send to, oh, here we go. That's quite WordPad. So the layout is just an XML representation that this tool uses. You don't really need to worry about it. But if you ever want to see the layout that you've created again, you can load it up again. And probably more usefully is you can export it to a C file. So let's create layout.c, layout.h, say, if we're going to put in a header file. Save that and open that. So Notepad, and there we go. So we've got the layout that we created. So it's just created a type def called mystruct by default, and in the comments there it's put the offset that we typed in, and you can see it's got the character array and the float x, float y, and the comments after that. So it's just kind of if you're reverse engineering a file, you can sort of, as you get more information, you can bring up that layout tool and add bits to it and then export it. So that's what that does. Okay, so under the File menu, we've got a few things we can do here. So obviously we can open files, as I did when I started this, so we could open the shapefile. We could reload, that's just over here on the toolbar there. We can write it, which we did before. Okay, so we can insert bytes. So let's try that. So say we want to insert 4 bytes at the start of